So, good evening and welcome to the week 7 of the Neural Science for Engineers, the live interactive session. The course instructor is Professor Vikas V from Nimhans, Bangalore, and I am the PMRF teaching assistant Vikas Pandey from IIT Jodhpur. This is a brief about me. For more details, you can visit my portfolio. The schedule is 6 to 8 p.m. Tuesday. The link remains the same, and all the recording of these lectures are also available on the YouTube channel. Or you can, for any query, you can write to my email. As we have discussed in the previous classes, that we will first go with a summary of the lecture, and then we will continue with our questions. Fine. So let's start with in continuation with the brain stimulation device. Now uh, we are discussing the brain stimulation device fabrication. It was. Do you remember what is brain stimulation and why is it being used? Mhm, 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 mhm. Yes. Mhm, yeah.
and
And
the total
total
size will
size
be
will
very
be very
small.
small.
And
And
one thing
one
board may
board may
contain a
contain
number
a
of
number of
lines also. So the main use is that we can Parkinson's disease and all. If we give this one, it can be the effect will be more. What I'm saying. The brain stimulation may help the patients to betterment of the previous situation and Parkinson's disease.
now, in continuation with that, we are discussing how to make these devices. So there are some basic challenges. First challenge obviously was in the previous class we discussed that since our body recognizes almost each and everything that comes from outside uh, as a probable threat, okay, and our immunity tries to attack on it, okay. So a solution was to use a flexible organic material like polyamide. Fine. Now, how these devices are made. So, as in the lecture, you must have observed that if we are taking a polyamide structure like this, so say we just want electrode to be here, and here we are creating pads which will be connected to the this via some interconnect. Okay, the whole thing has to be covered properly so that there is no short circuiting or anything. Only these 2 points are to be open and these two pads are to be open. Is it fine? Is it clear?
Yes, sir. Yes, sir.
Yeah. So the purpose of making this device was to deliver control, like control in the sense we know how much electric impulse we are giving and to which area. It will not go to any other area, and that also to correct some problem in our brain to create some impulses. So to fabricate these devices, we employ an intricate process where how electrodes are formed, and this whole process comes under the microfabrication. Okay, and as you might be aware that microfabrication is the same technology that is being used in creating sensors and other electronic structure like in semiconductor fabrication we use the microfabrication processor and chip manufacturing. They use this technique. Okay, so first thing that is the selection of the material, that is the polyamide that we are using as the insulator. Then the second is which electrodes we are using, gold or gold, titanium, platinum. Okay, then uh, some name of the techniques. I think to go in details of these techniques like lithography, spin coating, and reactive ion etching, there are some other courses available that you can go in, but we will be covering a brief about it. Fine. So technique like spin coating, in which suppose that there is a wafer. Whenever I am taking saying about a wafer, we generally say it is a silicon wafer, circular in shape. There are different type of silicon wafer, P type, N type. I think in physics till class 12th, these are covered, right? So, but how to identify which wafer? These are there is a course, MEMS fabrication for clinical perspective, by Hardik sir on NPTEL, and then one course I think again from Hardik sir. There is one other course also. So you can refer to these courses if you are interested more in that. Okay. So spin coating, let me briefly tell, is something like where we have a circular wafer, silicon. We are pouring a liquid over it. Okay. And then we are rotating it at a very high speed, say 2000 to 4000 RPM. So what will happen?
Yeah, because of the angular acceleration,
Yes.
centrifugal forces, it will go out of from the this one.
Yeah. A thin layer
Uniformly
will be
coated.
formed. Yeah, we
Uh,
uniformly coated, thin layer is formed. Okay. Then generally it is soft baked, like slightly heated so that it settles. Okay.
it
It
will stick into
fits.
that paper.
Yeah. Then there is another process called as lithography, which is the fundamentals, fundamental, or you can say a very crucial part. If someone says about microfabrication or processor making or fabrication, almost 80% of the cost is due to the lithography. That is so important part. And there are multiple stages of lithography in complex device. Okay. Litho means stone, graphy means carving. Okay. So from that, you can make out that we are making patterns. But here, when we are talking about lithography, we are generally talking about optical lithography. Okay. Optical in the sense this carving or this structuring is done using light sources, and that also in general 365 nanometer and 405 nanometer wavelengths are used. There are other wavelengths also, deep UV and all. These are what I am using in my lab, that is 365 nanometer. Okay, so here one more thing is employed, that is a photoresist material. Photoresist means it is again spin coated just like this, a liquid kind of resin which is sensitive to light. Okay, so if it is then again it is separated into positive and negative photoresist. So let's assume only one type, positive. Okay, so whatever area uh, is exposed to light, that will become soluble in a specific kind of liquid that is called developer, and the area that is covered, that will not be exposed. So a technique where we are putting a mask or a pattern which we want, okay, over it, and we are exposing light. Okay, so what will happen in this case? Are you getting my point?
Sir, actually, we have, from my personal experience, we
Yeah.
made panel boards. We board by this copper sheet and
Yes.
put that scale will make mark lines.
Yeah.
Then we
PCB
put into
making.
that liquid, PCB.
Yeah,
Then that only that part will be there. Other part
yeah,
will dissolve in that
these are,
chemical. I
yeah,
think same method only you are
same
using some
method.
precise one.
Yeah, same method, but at a higher resolution.
Higher resolution. But we
Yeah,
cannot make
and
nano and all
yeah,
with
and here, since it is higher resolution, we cannot do it manually. So we are doing it using these light sources and all, very precise light sources and all, right? So very similar to that. So what happens is that if suppose that this is the wafer, okay, we have spin coated over it, a photoresist material. Me, okay, and then on it a pattern like this is suppose a pattern like this is brought over it. Okay, a glass sheet, a, a glass with this pattern made over it, and this pattern is again made up of chromium. Okay, so opaque to the light. Okay, and then light is shined over it. Okay, so what will happen is that these area which were not covered by this black chrome will get exposed. So the next what we will do is that we will dip into developer, and this developer will remove all the parts, and what will remain is just this wafer with this pattern left. Okay, and other parts are removed. Now subsequently what we want is that below it also we want to remove all other areas. Then we do something like reactive ion etching, in which we remove the material. Etching, like you discussed the PCB making, no? There also you were dissolving the copper in some specific material, right? Acid, I think in acid you dissolve the copper. Okay, so these processes are used in which insulation layer is applied. Like after this, the whole thing will be covered with some insulating layer. Then again, patterning will be done. For electrochemical characterization, methods like cyclic voltammetry, electrochemical impedance spectroscopy are used to check the device performance. A very rigorous testing has to be done before moving towards putting it directly into someone's head. Okay, a rigorous testing, like in the previous class, also we were discussing that is it commercially available or not. So these things need a very rigorous testing and analysis before they can even be tested on a human being. So they have to be first characterized multiple times and with very precise instruments so that it can be used on some rat models and this, and then on primates, and then on humans. So it takes multiple steps. Then the next thing is that wired system. This whatever we are discussing is that we are putting something inside the brain at this specific point, and we are stimulating it via wire. But there is a problem with this, that they are limited. Then the person will have to be kept captive in a sense. Okay, that is why wireless systems are being used, in which a small part, very small module is kept there, and the control is through a wireless module. Yeah, just a minute.
Yeah. Uh,
yes, sir.
Hello.
Yes, yes, yes.
Okay. I think
So till here, did you get whatever we were talking?
Yes, sir. I got it. I think the same way what we do in PCB. Same
Yes,
way only
very
you are
similar.
doing, and you need more resolution for using
Resolution,
that
yes.
optic method
Yeah.
and
The
removing
next,
other material, taking all this material and put
yeah.
in insulated cover.
So there is a specific thing like this whole thing, though it looks very similar, but since it becomes very specified, it involves a separate discipline of study. You can say there is a separate bifurcation of if you are from electronics background or this, you will understand that there is a separate bifurcation later on in the field. Like this microfabrication and nanofabrication itself is a different field now, quite evolved. Okay. Then the next problem that comes is that if we are using wired systems, in the sense that we are uh, directly connecting the person to a instrument and all, then it will be a very difficult thing. The person cannot move. He will have to be latched and he will be kept captive. In that sense, wireless systems nowadays are used, in which we are putting some part of the module and the control part is kept somewhere else, like at a distance, where the person can be a bit mobile. He can move to uh, in a range. Okay, so in this case, one thing that comes into play is that batteries are used, then charge pumps. Since we have to use charge, uh, we have to inject charges, right? Then microcontrollers, small control or small processor along with a small memory where the codes are kept. Then there is one very important thing, that is current mirroring block. Okay, to achieve very precise stimulation. Current mirroring is a fundamental technique in electronics engineering for generating multiple current sources from a single source. As you might be aware, that in general we have standard voltage sources that are batteries or cell or these things. These are very common. But have you heard of a general current source? Yes. Any idea about any current source in like when we talk generally that this is a current source where a current is continuous current is being given out.
Now you are asking about battery systems, sir?
Batteries are voltage source, right? They give some fixed voltages like 9 volt, 5 volt, 0.3 volt, right? Are there any source that give fixed current, like 1 milliampere current will come from it? Are there some sources like batteries? Have you ever came up came across such things?
Actually, as per my understanding, when you connect something, that will draw the power current as per it is wattage. Like if you
Wattage,
put
yeah.
40 watts bulb, it will
Hmm.
take as per that current only.
Yeah,
So,
because in general, whatever we are using are generally voltage sources. Okay, there is one current source, but what we do is that we actually convert it into current source, into voltage source. That is, solar panels are actually one example of a current source. In them, direct the
sir,
electron flow is generated. Yes,
uh, yes, sir. Because I put my solar panel on my top of,
yeah.
floor, and I'm
So,
using electric car and scooter. So that
yeah.
is correct.
So, yeah, solar is a current source, but what we do is that we first store into a voltage source, that is battery, convert
Yeah,
it
yeah.
into, because our system is designed as per the voltage sources. Generally, we have voltage sources, right? But in this case, as we discussed, that we want current to be constant current sources. Okay, so we use a technique that is current mirroring technique. What it does is that it creates a current flow in one. Uh, arm of a circuit, and then we use multiple arms to create same current in the all the path. Okay, it involves transistor. Okay, and that also in saturation range. uh, Transistor saturation, if you remember that, transistor curve will be like this: cutoff, linear, and then saturation region. Okay, at the point where whatever voltage you give, current will be same. Okay, and this such multiple transistors are used to maintain consistent current flow. Okay, now the challenges in this current mirroring include transistor matching. They should be very well matched, their W by L ratio and all. We will not go that detailed in this. It is just something we can say that we are relating both the things. Okay, and ensuring that these transistors remain in saturation. Voltage source should also be very stable to maintain this current source, and resistance should not be variable, like it should have a fixed value. Okay, so we can say that this is some a very challenging part where a lot of work is still going on, have to be done. Okay, then the next section that was discussed in the lecture was human visual system. So we can say that the visual data from our eyes uh, are hardwired from the retina to the cortex. So they are like they transmit from the retina to the cortex. Okay, the integration occurs through corpus callosum connecting both the hemispheres. So, like in the center, there is something called corpus callosum, right hemisphere, left hemisphere connection. That part, this two, like we have two eyes, we have stereoscopic eyes, we can say. So they both the things are integrated. The signals are integrated there. There are some diseases that affect the level of visual system, leading to specific field defects. Okay, pituitary adenomas is one such disease which causes bitromia, bitem, bitemporal hemianopia, impacting peripheral vision. We cannot see the peripherals. Okay, optical tract lessons are also there that result in partial visual loss. Okay, cortical inserts typically spares the macula, preserving the central vision. Okay, so uh, that is fine. Understanding visual field defects will actually uh, help us in diagnosing and managing various diseases. Okay, the problem that is bitemporal hemianopia, that is a risk that is quite serious, especially when driving, because the temporal or the depth is gone. Okay, so these are uh, some of the things that were discussed in the lecture. Fine, now we can go for the questions. Fine.
Yes, sir.
Yeah, so let's start with our first question. This is something we have already discussed, we are repeating it. What is the primary function of brain stimulating device? To record brain activity, to stimulate specific areas of the brain, to analyze brain chemistry, to perform surgical procedures
To stimulate specific areas of the brain.
of the brain. And we are doing this so, for using controlled electric impulses. Okay, and that also for some therapeutic uses. Then, which material is commonly used as an insulator in the brain stimulating device fabrication? Gold, titanium, polyamide, silicon.
Polyamide.
Polyamide. And what is the reason for this?
Polyamide is a flexible insulator and it will not,
Yeah,
body will not taking as a foreign body also.
foreign, but like it will take, but we can manage it. Like it will not be that harsh. The body will not be that harsh on it. Like if we put silicon, it will react very differently. Okay. What is the purpose of lithography in the fabrication process of brain stimulating devices? To deposit metal evenly on the surface, to remove unwanted material from the substrate, to create a pattern for electrode placement, or to cu- cure the polyimide substrate.
To create a pattern for electrode placement.
Fine. And that can be done much precisely since we are using very precise source, that is light itself, and in some cases laser and UV light also. Okay, so that is much precise. Which technique commonly removes excess material from the substrate after deposition? Spin coating, photolithography, reactive ion etching, or curing?
Said na spin coating only while rotating RPM.
Commonly
Then
removes.
okay. You want to remove the excess material. That is photolithography or
That
etching. Oh,
patterns.
sorry.
That we have to
Okay.
remove that. Let's understand this
So
word,
I
right?
understood, but spin
Yeah,
coating first we have to do. Then
huh.
we have to mark a dark thing so that when you do
Photolithography.
photolithography,
Yeah. Hmm.
other things will be reacted. That reacted thing will do some other process and remove from that. So
Yes.
removing maybe ion etching.
Yeah, reactive ion etching or sometime wet chemical etching is also. Reactive ion etching is a kind of dry etching. Okay. There are some wet etching also. There are wet etching processes. But in case of, since we are using on polyamide, which is a organic substrate, wet etching is not possible in this case. Wet etching
Wet
is
etching
like
we do in our panel. That solution
panel,
we'll put it.
and yeah, even in my case where I am making the devices, I am going for wet etching because my case I am using algan or silicon metal, right? So they are not affected. But here, if you are dipping it into something like gold etchant, that will etch out this organic material polyamide also. Okay, so that's why we are not going for wet etching here. We are going for dry etching. Then there is a process curing. Curing is used to stabilize the film. Like I said, once spin coating is there, there are two type of curing. Sometime it is heated, and in some cases it depends on the material that we are spin coating. It heated or baked, we can say. Okay, and other it's UV exposure. Okay, these are two process of curing. Curing means stabilizing the film, or you can say drying the film in a simple sense. Fine. So the correct answer for this will be reactive ion etching. Yes, you are trying to say something.
No, no, sir. I just switch on, but I said reactive
Yeah,
ion etching.
yeah. So it is a dry etching technique, as I said, used to selectively remove material from the substrate, leaving behind the desired pattern of the electrodes and the interconnect. And how we are defining the patterns, that we are doing using photolithography. That is defining patterns. Okay, and defining patterns, and then we are creating a mask or a covering over it. So other things will be removed, only this area will be saved. Okay. What is the purpose of insulation layer in brain stimulating device fabrication? Is it to enhance conductivity, to prevent electrical interference, to increase device flexibility, or to facilitate electrode placement?
To prevent electrical interference.
Interference. So that we want that only at the precise point where we want the stimulation, there it should happen, nowhere else. Okay. They so insulating layers are applied on the brain stimulating device to prevent electrical interference between electrodes and interconnects, as well as like separating them from the tissue or the brain tissue or the brain areas that will come in contact. Okay, so that we can go only to the targeted brain regions. Which characterization techniques are commonly used to evaluate brain stimulating devices? X-ray diffraction, electron microscopy, cyclic voltammetry, nuclear magnetic resonance.
Which characterization techniques are commonly used to evaluate brains?
Yeah, we have made the device, but as I said, we are not going to directly put it into someone's brain. We have to check it multiple times, like to ensure what we want, what type of pulse or current we want, we are getting that. So how is it? What are the techniques? Is it X-ray diffraction?
Is
Is it
it electron microscopy or cyclic voltammetry? I don't know, sir.
since these are we can say electrochemical. These actually whatever stimulating devices we are saying, they are electrochemical devices, right? Because as we know that inside the brain, how the current flows, it is through ions, right? So there is a chemical current there. Okay, and whenever you are you come across electrochemical devices, cyclic voltammetry is one very common technique in which a fixed range of voltages is given, and something like you will see set and reset, uh, let's say from minus 3 volt to 3 volt it will be given and the current will be recorded. So the current can come something like this. This I am saying in case there is a separation, but if it is a ideal device, it will simply make one curve like this say this is 0 volt. Okay, so like it will depend on the device type. So this is a technique. X-ray diffraction is used in which case where we want to find the crystal structure of our material. Okay, so X-ray will be the material will strike with an X-ray and the reflected ray will be observed, very similar to Raman spectroscopy. Okay, then electron microscopy is simply where electron is used instead of light to see the object. That is for very small resolution uh, microscopy, you can say. It is just used to see. Okay, cyclic voltammetry I told. Nuclear magnetic resonance, here we are putting this is very similar to MRI, where resonance is matched with some nuclear atoms like radon, xenon, and these things. Fine. So it is cyclic voltammetry. Along with this, there are some other techniques that are used to characterize these stimulating devices. That is voltage transients and electrochemical impedance spectroscopy. Okay, cyclic voltammetry is where we continuously cycle through a set of voltages, not a set, like a range of voltages to see the set and reset cycle, like how it is responding. Voltage transients is again this, but in this case it is done over a time period, like some voltage is given and the fluctuation is observed. Then electrochemical impedance spectroscopy, where the impedance of it is checked under different electrochemical situation, like where in ionic form it is kept and then the impedance is measured. Okay, now next is, what is the advantage of wireless brain stimulation device over wired ones? Higher stimulation accuracy, reduced risk of infection, increased mobility and freedom of movement, or longer battery life. Yes,
Increased mobility and freedom of movement.
movement. Because we discussed that if we have a wired device, it is limited that the person will have to be at a distance, like he or she cannot go beyond it. But wireless will give us increased mobility and freedom of movement, as they need they don't need this close proximity and connection. Okay, so natural behavior analysis and experimentation is possible. Like you are not holding someone, he is able to move and freely respond whenever you are stimulating the person. Okay, so that gives better understanding also. Which component is crucial for generating constant currents in brain stimulating device? Resistor, capacitor, microcontroller, or transistor?
Microcontroller, but it having transistors.
Yes, transistors is there, but these transistors are uh, controlled using microcontroller. Nowadays, we are mostly using microcontroller to do these things so that we don't have to make circuits we don't have to manually make all the circuits. That's why nowadays microcontrollers are being used to supply constant current to brain stimulating devices. What is the primary function of a current mirror block in brain stimulating device? To provide wireless connectivity, to regulate voltage supply, to amplify current signal, to mirror and replicate a constant current source.
To mirror and replicate a constant current source.
Current source, right? Since we want the constant source, okay, yes, and thus we are able to get multiple current outputs, same current at multiple places wherever we need. There are many versions, like you must have heard that current conveyor or current mirroring was there, but current conveyor uh, was developed by two scientists while doing their masters. So they named it as CC second, I think. Yeah, current conveyor second, and now there is a improved version of it, CC second plus. Okay, so those techniques they have been successful in making this using the current CMOS technology, and that has led to a revolution, you can say, in case of instrumentation, where we are very easily able to understand the current through a sensor. Earlier, voltage was the only measurable thing or constant thing. Nowadays, current can be used, so current conveying circuits are quite commonly used in sensors. Okay, what is one of the challenges associated with current mirroring in brain stimulating device? Voltage instability, microcontroller compatibility, transistor matching, or brain weight
Microcontroller compatibility.
compatibility. Okay, it is the transistor matching.
Match.
Because why is it so? Because transistors you cannot make whatever you try, there will be some differences. Okay, you must be aware about W by L
Yeah,
ratio.
that is that
Yeah,
emitter and collector current will be ratio
yeah,
will be different.
different. Now it is source and drain we talk about. Ear- Earlier we were talking about emitter collector. Now source drain we can say, right? So W by L, whatever you try, there will be some error, and that also when you are making, they might be having small impedance mismatch. Then you will have to tune them properly along with some other circuitry. This matching is very important. Otherwise, the whole current conveyor thing or current mirroring will go in vain. Precise control. And that's why nowadays microcontrollers are used because they will do this task. Okay. So transistor matching is a important challenge at present also. Whatever we do, there will be some fluctuations. Okay. Okay. Which technique is not mentioned as a solution for generating multiple current sources in brain stimulating devices? H bridge, Z bridge, current mirroring, voltage regulation. Multiple current sources
Multiple current sources.
and not, which is
Current
not
mirroring
used.
only.
Current
I not
mirroring,
use that. Oh, Not
are
used.
not used. Yeah,
Then voltage regulation.
yes. Voltage regulation. H bridge, Z bridge, and current mirroring are different solutions how you can make multiple current sources in brain stimulating devices. This list is growing. Now, a lot of work people are doing in this field, so it will keep growing. But voltage regulation is not uh, used in the sense we cannot play with keep playing with voltage like you can say a feedback loop for the voltage to to control the current. That is not a way that we can do it. Okay, so there are other techniques. What is the significance of maintaining transistors in the saturation region for current mirroring? So as I discussed that for the current mirroring, if we see how a transistor behaves. So if you put a voltage between source and drain, uh, ds, yeah, ds means we are measuring the drain voltage with respect to source comes last. Then we are putting ids.
I
So
think this answer will be consistent current output only. No?
okay, to ensure consistent current output. Okay,
Current output.
yes. So seeing the graph itself, we can understand that this is the current, this is the voltage. So there is a range that generally till when it will not be on. In some cases, it is on also. Then it will keep going like a ohmic conductor that linearly. As the voltage increases, the current increases. Then it will go and get fixed. Is this the
This point
transistor
is
characteristic?
saturation.
Yeah. So this is the saturation range. Here, say like let's say this is 1 volt, this is 2 volt, this is 3 volt, 4 volt, 5 volt, 6 volt. Okay. So we can say that till 1 volt, this transistor was off, no current, whatever value of voltage it was. From 1 to 3 volt, as you increase the voltage, the current is increasing. But after 3 volt, in this case, the current is not changing whatever voltage you give. This is called as the saturation region. Cutoff
This is
linear.
when we buy a panel, solar panel, they give this diagram.
Yeah,
So
and that
using
all
this
the
diagram only
transistors.
I
Yeah,
calculate.
yeah. In all the transistors, solar panel itself is a diode. We can say, right? It's a reverse bias diode. Reverse diode, where instead of giving the voltage or current, we are getting because the photocurrent is being generated. So why we are maintaining this in saturation? So that whatever voltage comes, since voltage fluctuation is a problem. So say we are giving 5 volt, it becomes 5.2 or it becomes 4.9, still the current will remain same. Okay, that is the reason that we are using the maintaining the transistors in saturation region. And how can we maintain that? We will give more than this voltage. Okay, fine. So it is to maintain consistent current output fixed. Fine till here?
Yes, sir.
Yeah. What is the significance of, now let's come to the second part. What is the significance of the spinal cord in muscle control? It serves as a conduit for nerve fibers. So it is just a path for the nerve fibers. It is responsible for centralized control mechanism. So it takes care of all the control in the body. It houses distributed control system. So it has some control, not the whole control. It modulates muscle tone through spinal reflexes.
In this case, answer may be D, but C also may be correct. It houses distributed control system also there.
Yes, it is a distributed control system in the sense that some decision is taken there, as well as it works as a conduit for the nerve fiber. But it does not
It,
only act as a conduit for the nerve fiber, it is having uh, other function also. Okay, so some control is also there, as well as we can say it is working as the conduit for the nerve fiber. There are spinal reflexes also, but that is not the complete thing. There are much more functions than that. Fine.
okay, okay.
Yeah. So we can say almost uh, like A is also a bit correct, D is also correct, C is also correct, but the most appropriate, or we can say both, all three of these are correct, except for B, right? That it is not the
Yes, sir.
centralized control mechanism, but it is it serves as conduit for nerve fiber. It houses distributed control system, as well as it modulates the muscle tone through spinal reflexes, as we discussed in the previous lecture. Fine. So we can say even A and D are also correct. So all three are correct. Okay. Which brain structures are involved in high level control of movement? Spinal cord and basal ganglia, cerebellum and supplementary motor area, cortex and spinal reflexes, optical nerve and visual cortex.
Uh, Spinal cord and basal ganglia.
Spinal cord and
Otherwise, cerebral.
cerebellum and
Okay.
supplementary control. So whenever we are talking about higher level control, that means voluntary control, like moving the hand like this, that, everything. So that is from the CNS, central nervous system, right? And that actually is the cerebellum and the motor areas in the brain. Fine. Reflexes are controlled by
Fine.
spinal cord. Yeah. Okay. Now, what is the which part of the eye is responsible for high fidelity vision, like high quality of vision? Lens, cornea, optical disc, fovea.
Uh, from lens, it has to place somewhere. No? That is in for optic disc. That or fovea. I don't know, sir.
Okay. It is the fovea that is
Yeah, where
responsible for
the
high quality vision.
what is that, sir? Actually, fovea means the signal will
Fovea,
place that light.
uh, let me just let me,
Okay, we will discuss later, sir. We'll go
yeah.
finish.
No, if I put the image of it, I think you will be able to understand.
Actually, I
I thought
didn't
of,
completed that lecture. That's
okay,
why.
I thought of putting the image, but I forgot. Like I thought of putting the image here. Okay, anyway, I will put that. When I upload the slides, no, I will put it here so that it is easier to understand and correlate. Which of the following statements best describes the distribution of cones and rods in the human retina? Cones, there. Remember that there are two kind of
That I
cells.
know, sir. Cone for
Yeah.
bright light and rods for dim light.
Okay.
That I
Con-
studied in 10th class.
yeah.
That I remember.
Cones are evenly distributed throughout the retina, while rods are concentrated in the fovea. Rods are densely packed in the fovea, while cones are more abundant in the peripheral retina. Cones are primarily found in the periphery of the retina, while rods are concentrated in the fovea. Or both rods and cones are uniformly distributed across the entire retina.
Answer is B, maybe.
B. Okay. It is B because rods, which are responsible for vision in dim light, and they cannot rods using rods we cannot see color. Okay, and they are densely packed in the fovea area, where we say that it gives us the uh, high quality resolution, right? While cons, which are responsible for color vision and high resolution details, okay, like spherical and these things, they are more abundant in the peripheral retina. Okay, so this allows for optimized vision in different lighting conditions. Okay, so when we are talking about this, let's ask one more question: is what distinguishes the human eye's vision from conventional sensor design, as discussed in the lecture? The human eye sensor captures and reacts to photons primarily for their energy content. Conventional sensors are more complex and interconnected compared to human eye receptors. The human eye visual system processes data encoded within photons rather than solely capturing their energy. Or conventional sensor exhibit non-uniform distribution of receptors similar to human eye. How is it different? If we talk about sensor or any, let's talk about our phone camera system and all. This is the visual system, right? So how is it different than our human?
I think it is. I think it is A only, sir, because bright light comes, we'll blink our eyes.
Uh, it is saying that human eyes work only with the photon energy. Okay, but is it true?
No, I am saying it is movement. Photon energy, sensing the energy and it move. No, it's not correct.
No, because
Then
there,
otherwise, see, sir. See.
see, but C is again correct.
Which one,
Yeah,
sir?
C is
See only,
correct.
no?
Yeah,
Ah.
C is correct because it is not only the, like in case of camera, what happens is that it is just the intensity or the energy that is captured. Whereas in our eyes case, it is not only the energy, it is much more than that. Okay, uh, it is it processes the data encoded within photon. So it is much complex than a simple photo sensor. So it is not just light detection, but it is about the human vision system. Like it is much more complex than that. Whereas in case of camera and all, it is just the light, or like it is opened and the light comes, and based on that, a image is formed. Right? Human vision is much more complex than that, as we can just see by the uh, structure of the rod and cones. They are non-uniformly distributed, and that makes it much much advanced. Whereas in case of lenses and all, the whole sensor is uniform.
Is data encoded within photons means what actually?
Uh, like seeing something, we we make out a lot more than just an image. It's dark, black, red, white. Apart from this, we are able to see a lot of things like depth. We are able to uh, understand the something is front or back, right? This whole processing is able to do like if some light is coming from far and something is coming from nearby. Okay, our visual system is able to differentiate it, right?
Okay,
Like
okay, okay.
that part of things. Like you can say that it is much more. It has much more sensory role than just a receptor, right? It is not just a receptor. It is playing some sensory role also, as well as it has some processing and these things also. Okay. Yeah. Now next is what is the key difference between conventional nerve and photoreceptor? We have learned about conventional nerves. and photoreceptors, that is, in our eyes, in terms of their response to stimuli. Conventional nerves become hyperpolarized in response to light, while photoreceptors become depolarized. Conventional nerves release neurotransmitter in response to darkness, while photoreceptor response neurotransmitter in response to light. Conventional nerves uh, have open sodium channels in darkness, while photoreceptors have closed sodium channels. Conventional nerves have closed sodium channels in darkness, while photoreceptors have open sodium channels. How are they different?
Sorry, sir, I didn't cover that part. I will cover
So,
next week.
yeah,
We'll discuss these things in next week, sir.
yeah, only two more questions.
Two
I
more
will
questions.
put them.
Okay, okay.
We can anyway we can discuss again also, not an issue. So, in conventional nerves, sodium channels are typically closed in the resting state or the darkness, you can say. While in photoreceptors, the sodium channels are open in resting state, leading to depolarization in neurotransmitter release. Okay. So, what is the purpose of optical charge in the visual pathway? To enhance visual acuity, to process color information, to integrate signals from both eyes, or to control eye movement. So, as we discussed in the summary section, it is to integrate signals from both eyes,
Both
where
eyes.
the fiber from the nasal retina of each eye cross over to the opposite side of the brain. So it is something like the right one will go to the left and left one will go to the right, like crossing over occurs from the center of the brain. This crossing allows for integration of visual signals from both the eyes. Okay, this stereoscopic vision and these things are result of that. What visual effect is commonly associated with pituitary adenomas?
Bitemporal
Quadranopia, yeah,
hemianopia.
bitemporal hemanopia, okay, which is due to the compression of the optic cell leading to loss of the peripheral vision in both temporal fields, known as bitemporal hemanopia. And this is something uh, that people of old age often suffer. That's why this while driving they are not able to make out the distance and all, because our stereoscopic vision allows us for this distance and all. Okay, so anything from this you would like to ask or clarify, get clarified?
I think they're fine.
Fine.
I will see that eye part also by next week.
Yeah, and like half of it is covered here, and I think in the following week some part is there, so we can cover that again. Okay, so that's all for today.
So 6 weeks
See you in the next one.
completed, sir. So,
Yes, 7 weeks
sir,
complete.
sir,
No, 6. Yeah,
I'm attending all the classes without any absence. So you should give me at least 50 marks for that.
uh, it's